Hello, everyone. Welcome to our webinar today. This webinar is being presented by the Clean Energy States Alliance, and the topic for today's webinar is Tools to Tackle Affordability and Cost Allocation in Electricity Rate Design. The date today is November 6, 2025, and we have an excellent panel of guest speakers with us today, but before I pass it over to them, I'd like to go over a few webinar logistics. All attendees are in listen-only mode, so your webcam and microphone are disabled. The chat function is also disabled, so if you would like to submit any questions or comments, you can do so via the Q&A panel. We'll be saving about 15 minutes following the presentations to address audience questions, so be sure to type your questions in as you think of them during the presentation, and then we'll get to them at the end. Automated captions are also available. Speakers' bios will be made available in the chat as the speakers are being introduced. And finally, this webinar is being recorded. We will email you a webinar recording within 48 hours, and it will also be posted on CESA's website at cesa.org/webinars. And with that, I'd like to pass it over to our host for today, my colleague Anna Ziai.
Thank you, Zareen. Hi, folks. My name is Anna Ziai, and I'm the Project Director of Federal Initiatives at CESA. CESA is a national nonprofit coalition of public agencies and organizations working together to advance clean energy. And we work with state leaders, federal agencies, industry representatives, and other stakeholders to develop clean energy programs and inclusive renewable energy markets. CESA members, which mostly comprise of state agencies, include many of the most innovative, successful, and influential public funders of clean energy initiatives across the country. And you'll be able to see our members' logos on your screen in just a moment. Okay, great. Here they are. And next slide, please. This webinar is actually a part of the CESA Federal Initiatives Project, which provides opportunities for CESA members and all U.S. states to learn about federal energy developments and exchange information to advance energy deployment in their state. So this includes a few key things. It includes keeping participants abreast of federal policies and funding opportunities via the Federal Energy News newsletter and by bringing in industry experts to our meetings and calls. By helping them leverage and request technical assistance provided by CESA and partner organizations, and by sharing best practices and peer learning in energy program design and implementation among states in different regions. All right, next slide, please. So today we're going to learn about different tools provided by and maintained by the National Renewable Energy Laboratory, or NREL, to help stakeholders address affordability and cost allocation in rate design. So you can see our panel of experts from NREL on your screen, and I'm going to give a very brief intro of each of these panelists, but I encourage you to read the PDF with their bios, their full bios, in the chat that Zareen is going to be posting, and you can learn more. So our panelists today include Brittany Speetles, who's a researcher at NREL and whose research includes topics such as demand flexibility, virtual power plants, and retail electricity rates. And we also have Joyce McLaren, who is a senior researcher at NREL, who leads a range of technical assistance and analysis on solar markets, energy storage, electric transportation, grid interactive buildings, and of course, rate design. So let's get started, and I'll turn it over to Brittany. Thank you.
Thanks, Anna. We could go to the next slide, please. Yeah, so today we'll be talking about some of the ways that NREL has to analyze retail rates, so tools to tackle affordability and cost allocation in electricity rate design. I'd like to start with some housekeeping. So this slide just overviews our agenda for today. So first, I'll go through some of the challenges of today with respect to retail rates, and then Joyce is going to overview NREL's rate analysis capabilities. And then next, I'll walk through an example of a past project involving retail rate analysis at NREL about demand charges in the electricity sector. And then Joyce is going to talk about how to tap into NREL resources. And we expect to have some time left for question and answers at the end of the webinar. Just a quick note that this webinar does not discuss preferred rate designs. So the intention of the webinar is to increase awareness about the technical support that NREL can provide with respect to retail rate research. Next slide, please. So first, I'll go into the rate challenges of today. Next slide. Rates are the lifeblood of the electricity system. They determine how customers pay for electricity, and they fund investments to help operate the grid. Rates are developed by utilities to recover costs and are approved by regulators. The figure that's shown here on the right is from the Regulatory Assistance Project, and it shows how utility revenue targets are translated into rates to recover certain types of costs and allocated to different customer types, such as residential, commercial, and industrial customers. Regulators evaluate rates using several widely accepted criteria, which come from the bond right principles. And these include the 4 criteria listed in this slide, namely revenue sufficiency that dictates whether utilities make enough money, customer understanding and acceptance of rates, fair cost allocation that apportions rates to certain customer classes, and encouraging efficient customer behavior, which supports energy efficiency, energy management, and storage to help the grid. Next slide, please. Retail electricity rate design has developed over decades as a mechanism to ensure the fair and efficient recovery of costs of serving electric customer load. Over the years, the process of setting electricity rates and the rate designs themselves have been refined, and in many cases, they become more complex. So more complex rates are emerging with factors such as more variable marginal costs and increasing fixed costs, and new priorities, cost drivers, and technology. So more specifically, factors like electrification, flexible loads, and advanced metering. The graph shown on the right shows the adoption over time of advanced metering infrastructure by customers, which is shown by the blue area graph. And AMI, or advanced metering infrastructure, has enabled more time-varying rates for customers. But even still, even though 90% of customers as of 2023 have advanced metering infrastructure, and even though an increasing number of utilities have offered time of use rates, there has been relatively minor customer uptake of time varying rates in the residential sector. The next slide. Building on the last slide, the electricity system as a whole is undergoing shifts, and it's important to track the impact of these shifts on retail rates. So in general, there are changing and emerging types of loads and energy use patterns that are becoming more important for the electricity sector overall. For example, new large loads from data centers and manufacturing, growing electric vehicle adoption and charging, building electrification, and generally more variable generation, energy storage, and smart assets. There are also several macro trends that are shaping the electricity grid of the future, including rising costs of serving load, major weather events, aging infrastructure, and grid hardening. And together, these changing loads and energy use patterns spur questions about utilization of new and existing assets and infrastructure. I think we're going to move on to a quick poll question for the audience next. So the poll is, what are your biggest concerns related to rate design? So there are several options here, and you can just use the pop-up poll to vote on that. And it says other, please type into the chat, but I don't think you actually can type into the chat, but you can type your answer into the Q&A area. So I think we'll just give it a couple minutes for people to select their answers, and you can choose up to 3 in this multiple choice poll. I'm actually not able to see if people have answered, so maybe Serene or Anna, if you could let us know.
Sorry about that. So the top answer is maintaining affordability for customers. The second most popular answer is customer ability to understand and respond to increasingly complex rates. And the third most popular answer is increasing transparency of rate design. followed by ability to accurately recover costs.
Great, yeah, and that makes sense. Based on our audience, which I'm thinking is a lot of like state energy offices, yeah, keeping rates affordable is really important, and it's sort of a topic for discussion right now with a lot of, and always a topic of a discussion as the electricity grid and electricity topics change so quickly. So that totally makes sense and is something we will get into more here in this webinar. Awesome. I think we can move on to our next poll question, which is, what tools do you use to conduct rate analysis? And just sort of at a high level, do you use internally developed or third-party tools or consultants? Looking at others' analysis through like literature reviews or similar, or none of these? And again, it would be interesting to see what types of third-party tools folks are using. So again, you can use the Q&A box. See, someone said REOPT, which is a tool we'll be sort of discussing going through today. Awesome, interesting. It looks like 46% said they do not engage in rate analysis activities. And then the second most popular answer was internally developed tools. So that's, yeah, that's good to know. Just getting to know our audience a little more. Great. So I think we can move on to the last slide of this section. So yeah, so our motivation for this sort of webinar today is that affordable and reliable energy depends on well-designed electricity rates. The primary way that people interact with the grid determine their bills and guide investment. So retail electricity rates are really important. And for commercial and industrial customers, rates impact economics and drive business decisions. For residential customers and consumer advocates, rates impact energy affordability and household energy burden. And for regulators and utilities, well-designed rates can enable accurate cost recovery and efficient customer response. Yet rates are growing more complex as new technologies and large loads come online, and this makes it more difficult for rate-paying customers, advocates, and regulators, and others to assess affordability, fairness, and system impacts. Sometimes the current widely used tools may offer bespoke analyses, and other times they may be slow to respond to current issues. And decision makers really need tools that accurately evaluate rates and respond to the changing electricity system conditions of our time. So we'll dive into more about the rate analysis capabilities that NREL can offer, and I'll turn it all over to my colleague Joyce to go through that.
Thanks, Brittany. So yeah, NREL has multiple capabilities and tools related to electricity rate design that I'd like to introduce in the next few slides. And then we'll be showing you an example of some analysis that we have recently done regarding demand charges. And the idea really is to get your ideas flowing of how NREL might be able to help you answer your own questions related to rate design in the future by collaborating with us. So the so NREL can really help you in a number of different ways. And this list is meant, if you can hold this in your mind as we're going through these different tools and seeing how we might help you answer your questions. We can do things like help you track new and current rates, understand historical or regional rate trends, model the different impacts of proposed rates or even existing rates on customers. If you're trying to compare different options, understand the interplay of rate design with different technology adoption levels, electrification levels, or new loads, and understand how modern rates in general can meet the changing grid conditions that you're experiencing in your region. The next slide, please. These are 4 different capabilities and tools that we have at NREL that I'd like to highlight. And some of these I'll go into a little bit more detail than others. But on the ResStock, Comstock, and UrbanOpt tools, these are things you might have heard of in the past. They've been around here at NREL for quite some time. And ResStock and Comstock provide comprehensive bottom-up modeling of how different types of buildings use electricity. So these models generate highly detailed load profiles for residential and commercial buildings based on individual end uses within the building. And then UrbanOpt adds the spatial and aggregation dimension to that, and the interaction with different distributed energy resources that are located on a distribution system rather than at the building level. So in combination, these tools really provide a really robust way to analyze building loads. And rate analysts can use these tools to help them identify which loads may have the highest value or potential for flexibility, and to align rate signals with the opportunities for demand side management. They can use it to understand how demand peaks change due to different technologies, like distributed energy resources, or changes in customer behavior even. You can identify when demand peaks might occur, to inform things like time of use rates or critical peak pricing, or understand how proposed rates might impact customer bills, or even estimate revenue changes for the utility based on these changing building loads. So these are really some powerful tools. On the top right, the utility rate database is a database of, as it says, utility rates across the country. It covers very many of the utilities, large and small, across the country. It doesn't have 100% of the utility data, but of course we're always hoping to improve that data, and we're looking for ways to collaborate with folks to make this database as complete and accurate as possible. I'll go into a little bit more detail on that database in the next slide, but I'll go on to introduce a little bit about CAIRO. Actually, I'll have another slide about CAIRO too, but CAIRO helps us develop and model and evaluate the impacts and trade-offs of different rate designs. And it's really comparing different design options based on the electricity system as a whole, which is very different from Comstock and ResStock, which is just looking at building loads. I'll give you some more detail about CAIRO in just a moment. But then I also wanted to highlight the geospatial analysis capabilities that NREL has. And I know that many organizations have GIS capabilities in-house or mapping capabilities in-house. NREL staff can usually share data sets that we have already formatted with your GIS teams to facilitate your own in-house analyses. And I know that some of you indicated that you do in-house analyses. And so we can support those. We can support your visualization efforts. Or if you don't have those capabilities in-house, we could perform those for you. So most of our tools are publicly available. But even with the open source tools, there are nuances about how to use them correctly, how to understand the outputs, make sure that you're getting your inputs in there right. And NREL staff is always happy to work with you to make sure that you're using our open source tools and data sets in the best way to answer your questions. So next slide, please. So the utility rate database, I'll just highlight a little more since it's a really popular resource. It details the rates in every sector for utilities across the country, and breaks down each rate into its component parts. So for instance, it breaks out what's the fixed charge, what's the kilowatt hour charge, and what's, for instance, the demand charge. Or it'll show all of the different time blocks for a time of use rate. So it's a really great tool for understanding the details of a particular rate. And you can look up those rates by utility, by zip code, by county. It's really quite flexible. The database is already integrated into many NREL tools that pull those rates. And it's also accessible through an API, so you can incorporate it into your own tools. In a lot of cases, historical rates are retained. So if you want to look across time at how rates have changed, that's also possible. So the next slide is about Cairo. And my colleague Thomas is on the line and can answer more detailed questions about Cairo later, but I'll just introduce it here. Cairo helps you develop and model and evaluate the different impacts and trade-offs of different rate designs under both the current and the future power system conditions. So it can develop both a historical baseline and forward-looking scenarios. And users can look at either the existing or the proposed or theoretical rates and compare their impacts on both the customer side and the utility revenue recovery side. So bill impacts, affordability, revenue recovery, and the metrics that it's using are based on those Bombite principles that Brittany was calling up earlier, which include affordability, customer bill stability, economic efficiency, and fairness. The graphic on the right of the slide is showing an example of an analysis that was done with Cairo, and it's showing the calculated monthly bill for different customer classes under several different rate designs and programs in the LADWP utility territory. It's comparing a 2019 baseline to a 2035 scenario. And the scenario that's in green on the far right is indicating the most affordable option. And we don't need to go into the details here, but this is just to kind of demonstrate the type of analysis that you can do with Cairo and the type of outputs that you might expect. So Cairo is an open source tool. It's very flexible. You can use a variety of different data sources. You can use AMI data, open source data sets like ResStock, or you can use more granular data that you would have available if you did. So if you're interested in learning more about Cairo, of course, we'd love to talk to you about it. And we do have Thomas on the line to answer questions later if you have any. Next, I'm going to pass it back to Brittany to give us an example of another rate design related effort that we've recently finished up at NREL that is actually kind of a follow-on to a 2017 effort that we had on demand charges, and it was really popular. So we continue to look at demand charges and are interested in understanding their impact on different customers and on the utility. So Brittany, if you'd like to take it away and introduce that.
Awesome. Thanks, Joyce. I think we can go to the next slide. And yeah, as Joyce was alluding to, this project, it's called Demand Charges in the Electricity Sector, and it was funded by the Office of Electricity and the Department of Energy, and just really looking at different sort of factors about demand charges, which I'll go through in the next few slides. So in this project, we analyzed how demand charges vary in the US using the URDP, which Joyce sort of went through, the utility rate database and Tableau, some of our geospatial analysis software that we use here at NREL. And then we also looked at the historical context of how demand charges sort of came to be and how they evolved over time, dating back to like the 1890s when electricity was invented, and then over time all the way into the present day, and how demand charges are implemented currently in retail rates. We also conducted interviews, about 30 interviews with rate design experts ranging from academia, industry, utilities, etc. So conducted a lot of interviews to just determine how people are thinking about demand charges in line with some of the Bond-Bright principles, and in other ways. And then we explored how demand charges relate to widely accepted rate-making principles and current and future electricity system topics, like adoption of new technologies like DC fast charging and battery storage. Oh, and just a quick note, the results of this project are in a technical paper, which is pending release. So if you could just not cite the next few slides, that would be amazing. Next slide, please. Awesome. So just to make sure that everyone is on the same page about what we're talking about when we say demand charges, demand charges are based on a customer's level of electricity demand over a specific period, and they're denominated in dollars per kilowatt. And demand charges are typically used in conjunction with energy charges, which are measured in kilowatt hours, and fixed charges, which are like a fixed charge per month or per billing cycle, to comprise the utility rate structure. And they're widely used for commercial and industrial electricity customers to recover significant portions of utility revenue. And increasingly, they're being integrated into residential rates in a modest but growing number of locations. So they help to recover capacity and infrastructure costs on the transmission, generation, and distribution levels. And demand charges can also vary in the way that they're structured and implemented. So for example, the dollars per kilowatt rate can vary based on the month of the year or the season. And demand charges may be higher in the summer in some locations, especially where there's a summer system load peak, for instance. And the magnitude of the dollar per kilowatt charge can also vary for a subset of peak hours, or the utility could employ other tactics, such as a ratchet or a contractual term to determine the demand billed for. The length of time over which the highest demand is averaged is called the integration period. And this is often 15, 30, or 60 minutes for industrial sector customers. Advanced metering technology allows for more flexible methods in setting the integration period, such as taking the average of a customer's 2 highest demand hours during the month. So sort of design variations exist within demand charges, but this slide really is just trying to summarize all the ways that they can vary. Next slide, please. So in this slide, the table presents our expert opinions on demand charges, which were gathered through the individual and semi-structured interviews and focus groups of a variety of experts from academia, utilities, public utility commissions, consultancies, research institutions, and nonprofits. We interviewed a total of 30 individuals, either individually or in groups. And together, this contributed to a broad understanding of how demand charges are currently implemented in various jurisdictions across the United States. The purpose of the interviews was to gain a robust understanding of the opinions about demand charges and use them to advance the conversation about demand charges in the current era. In our paper, we used these 4 widely accepted rate principles shown at the top: the effective cost recovery, customer understanding, fair cost allocation, and efficient customer behavior, to really categorize all of the insights that we gleaned from the expert interviews and to discuss the trade-offs between these regulatory objectives that may be relevant as the electricity system evolves. And so just as an example, I won't go through all of these 4 in detail, but for example, for effective cost recovery, for both vertically integrated and distribution-only investor-owned utilities, demand charges can be significant in cost recovery for commercial and industrial customers. So if demand charges were to go away, then that revenue would still need to be recovered through other avenues. And demand charges can support cost recovery. And that's often a key motivation for demand charge adoption in C&I sectors. But they may give less incentive for customer load shifting than other time varying rates. And so increased adoption of technologies that help customers reduce or avoid demand charges, such as battery storage, might also be another factor that lowers utility cost recovery from demand charges in the future. But that is to be determined. So yeah, so I can go into the others in detail during Q&A if that's of interest, but for now, let's move on to the next slide. So this is just showing some of the data analysis that we conducted as part of this project. And the map on the right here includes small commercial, large commercial, and industrial demand charges. And it displays demand charges in the utility territories that are annually updated in the utility rate database, which collectively account for about 70% of total US electricity load. But there's also some utility territories in this map that are not annually updated in the URDB, but happen to be updated in the past year or were reviewed for this project specifically. So this map shows the demand charge variation across the United States, and it shows it for utility service territories, which might cross state lines. The dark gray areas on the map are updated in the URDB, but are locations where there isn't a demand charge in the rate. And then the light gray area, which is like the same light gray as Mexico and Canada, are areas where the data isn't adequate or available. So this map is still a work in progress, and we're currently comparing several methods to display the utility shapes on this map of the US. And this is one of those options, which uses EIA codes to project the demand charges. And on the left here is a box and whisker plot. And the box and whisker plots are specific to sectors. So commercial and industrial sectors are shown separately. And then seasons are also shown separately. So the orange dots are for summer, and then the blue dots are showing the winter months. And in the box and whisker plot, just note in the commercial sector that large and small commercial customers are grouped together. And in this plot, the median, which is like in the middle of the box, in the box and whisker plot, is much lower than the overall spread. So the rates are mostly concentrated around the 10 to 20 mark in $10 to $20 per kilowatt mark in the commercial sector, and 5 to 15, about 10 to 20 mark in industrial as well, maybe 10 to 15, a little bit more sort of concentrated in industrial sector. And then it also shows that sometimes, especially in the commercial sector, rates are sometimes slightly higher in the summer. Next slide, please. Awesome. So this map on this slide shows residential demand charges. So similarly to the commercial map, the map displays demand charges in the utility territories that are annually updated in NREL's URDB that account for 70% of US electricity load, but also some utility territories that are not annually updated, but were looked at for this project or have been updated in the past couple of years and were sort of in our timeline that we were looking at. So the map shows the demand charges for residential customers, and as there are no residential demand charges in Alaska and Hawaii, we're only showing the contiguous United States here. And again, the darker gray area means that there's no demand charges in those locations, and the lighter gray is areas where we have no data. On the right side, there's also a table where we show the percent of residential customers with demand charges on their bills. So we used FERC Form 1 to determine that in the majority of cases, residential demand charges that are displayed on this map are opt-in and they're not default, and they have low customer enrollment rates, sometimes or most often less than 1%, with the exception of Arizona Public Service Arizona Public Service Co., which has had sort of more luck with rolling in residential customers onto demand charges. And also jumping over to the box and whisker plot on the left, again, even though the range might be higher, a lot of the rates are concentrated around like the $5 to $15 per kilowatt mark. And again, just noting that this map is a work in progress and we're still sort of working with the data to determine just the best method to display all of this great information. But this sort of just gives a sneak peek of NREL's capabilities in analyzing the scope and of retail rates in the US. So I'll turn it back to Joyce now, and Joyce will go through how to tap into NREL resources.
Great, thanks, Brittany. We can go on to the next slide, please. Yeah, so just to wrap it up, the changes in the industry, including the load growth, the new industries and new technologies, both on the demand side and on the system side, are really calling for new approaches to rate design. And transparent data and analysis tools are really critical to being able to make informed decisions in this changing environment. So NREL is aiming to provide reliable data, help to decision makers, and any kind of tools and resources that are needed to ensure fair cost allocation, empower consumer advocates and regulators with transparent evidence-based insights, to ensure affordability. And we're really wanting to hear what your needs are in these areas. What are your pressing questions about rate design, about the future of rates, the impact of different rates, and what are your needs? What are your analysis needs? What are your data needs? And how would you like to collaborate with us? So again, you can go to the last slide. I'm just going to highlight the things that I mentioned before, things that we can do, ways that we can work with you, different tools and things that we would like to continue to build out in ways that are most supportive to answering your questions. So we'd really like to hear from you. You can do that in a number of different ways. You could simply just email Brittany and I. You could get in contact with some of the folks that are listed on the NREL website that are associated with these tools and resources that we've highlighted today. Or you could contact you can contact NREL. If you already have a contact within NREL, please just get in touch. So we're really urging everybody to share with us what your questions are, what are your most pressing needs, and how would you like to collaborate with us. So that's where we'd like to end it today, and we'd love to hear more from you in the Q&A. And oh yeah, we have one final poll for you. What are the most relevant issues for you to analyze with respect to rates? And we have a place to type in your answer there, but if you'd also like just to unmute yourself and let us know during this Q&A portion, then we're happy to chat about it there too.
Great. Thank you, Joyce. Well, we'll give folks just a moment to get those answers in. Again, you can submit them in the Q&A function, and then we'll dive into some questions. Thank you to folks who've already submitted. There's a lot of good ones in here. So I'll give folks just a second. Okay. Well, while folks are finishing up their answers to that, let's get started with some of the questions that we've started collecting for Joyce and Brittany. So just before we do that, actually, let me quickly say for those who weren't here at the top of the call that this webinar is being recorded and we're going to be posting the slides in PDF format on the website, and we'll send everyone who's here, we'll get the link to that. So you don't have to go looking for it either. You'll be sent that in an email after the fact. So our first participant asks, does NREL have tutorials online to learn how to use the rate analysis tool?
I'm guessing they're talking about Cairo in particular. I don't believe we have a video tutorial of how to use Cairo. Thomas might want to jump in here since he's the Cairo expert, but Thomas, are you on the line? There he is.
Hi, can you, sorry, I had to rejoin as a panelist.
That's fine. We've got you now.
Yes. So there currently is no video tutorial yet. We're hoping to develop more training material for Cairo, assuming that this is about Cairo, by early spring 2026. So we are pulling together that material now. If you yeah, I mean, it's also good to hear what kind of tutorial material would be most helpful because we're very early in the development phase of this stuff. And so if video tutorials are the easiest way to do that, we'd love to hear that.
Okay, great. So folks, yes, please go ahead and write any insights about that if you have particular video needs that you'd like, tutorial needs, and I would love to know. Okay, great. So next question is, does the utility rate database work with API calls, and how frequently is it updated to match current rate cases?
Yes, I can take that. Yes, there is a URDB API, so it interfaces with other NREL tools like Reopt and SAM, as well as actually, yeah, I think that's the main ones, but maybe there are some more that it interfaces with, like, I'm not sure reads, but it does have an API, and it's updated, I believe, once a year for a lot of the rates in the US. Like I was saying in the maps, the annual updates go through 70% of overall load in the US. And so a lot of those updates annually focus just because of like how utilities are set up in the United States. A lot of the load is from investor-owned utilities, but some sort of select smaller utilities are also updated. And then there's a URDB team that can update other rates of interest, just sort of ad hoc.
Awesome. Thank you. All right, next question is back to Cairo. Does Cairo focus on retail rates only, or does it include commercial and industrial rates as well? And then also, can it be downloaded and used?
Yes. So currently, we have more experience running for residential, but it's like it is sort of agnostic as to the types of customer. It analyzes rates on a customer class basis. So if you wanted to do industrial, you could look at industrial, and the types of rate components that you would want to include differ, of course, by customer class. But Cairo has the ability to look at minimum bills, time varying, energy charges, demand charges, net billing, net metering. So you can look at all these different types. So you can build effectively what's the kind of rate that I would like to see, and then you pass it the loads that the rates are being applied to, and the revenue you would like to collect. So I guess my short answer is that yes, it can look at commercial, it can look at industrial. We have a lot more material out on how to use it for residential because that's where it's been primarily focused on affordability purposes. And then the second part of that question I missed. Anna, can you repeat that for me?
Yeah, just if it can be downloaded and used.
Yes. So Cairo is completely open source. It should be available on NREL's GitHub repo. and it's written in Python. So should be available for anybody to download if they want. And again, like training material on actually how to do it is forthcoming.
Great. Thank you. All right, next question is, can you speak more about demand charges for residential customers? They were just approved in Nevada for the Nevada Energy residential customers.
Yeah, awesome. Yeah, I was kind of anticipating that question. I even thought about mentioning it on the residential demand charges map. But yes, we are aware of that change. So this is an example of things changing quickly in the electricity sector. So we made this map like a couple of months ago and are planning to just update it right before the paper is approved for release. So yes, we are aware of the new Nevada Energy residential demand charges.
That's great. All right. So based on the slide that was titled Demand Charges Are Widely Used in C&I, which is commercial and industrial sectors. I don't know if we can pull that up, Zareen, but if not, it's okay. I think it's like slide 20 of the NREL slides. Someone asks, why is the commercial range so much greater than the industrial range? Any simple explanation?
Yeah. So one driver could be that the commercial sector includes, everything from small storefronts to much larger customers, which could result in greater heterogeneity in demand charges compared to other sectors. And there's also a more pronounced sort of summer to winter variation in the commercial sector than in the industrial sector. Which could relate to the use of different end uses, such as air conditioning in the summer, which could raise demand and then make demand charges a more important cost signal and cost recovery tool in the sector. So industrial loads may be less reliant on certain sort of seasonal variation between seasons as a percentage of demand than commercial loads, and may have just a more homogeneous demand profile year-wide. So it may not be as important to give those customers a price signal that varies by season.
Great, thank you. And I think it was the next slide after this one that our next question comes from, where a participant asks, any idea why the outlier of 17.6% in APS territory?
Yeah, I think APS, and I know someone else commented that this is only for rooftop solar customers. Demand charges for APS in the residential sector is for rooftop solar customers. I think that this has just been a long-standing sort of price signal option in APS. Another thing that APS does is that each year they sort of recommend a rate that they think customers should use based on their past load over the past year, I think it is. And then they recommend a specific rate that a customer should be on. And I think sometimes they recommend that they use the one with demand charges. So that might be a reason for the higher percentage there.
Great, thank you. And this one is a bit more of a general question, but I think it's also very important. Someone asks, are there rate structure concepts that you think could increase affordability for residents, especially as we shift toward a more decarbonized future?
I can,
Yeah.
oh, Thomas, you take it.
Yeah, so I guess, like, I've seen a couple of rate elements that are specifically oriented towards improving affordability, in particular for like low income residents. So, the original income-based fixed charges approach that was explored by the California Public Utility Commission, like that's one where you see like a absolute top level regulatory priority on improving low income affordability. I've seen more theoretical approaches like payment as a percentage of income. A lot of these things that are where you're trying to provide benefits to low income residents in particular, you run into issues with income verification, and especially how you keep that updated. I would also say that there's like different affordability concerns that come with each type of rate element. So you can imagine that a regulator wants to implement time of use rates, but they're concerned about the ability of low-income residents that don't have a lot of programmable technologies to respond to those. So I hope that answers the question, at least, that there are some elements that are sort of strictly focused on low-income affordability. There are other elements that you can look at different ratios of how much revenue you want to collect from a fixed charge or a demand charge or an energy charge. But then you start running up against other priorities, like, is this rate can you actually interpret this rate and adjust your behavior accordingly?
Got it. Thank you. All right, next question is, does NREL have any tools that apply to natural gas rates?
I'm not aware of any, but maybe Thomas or Joyce.
So I'll jump in that Cairo does estimate natural gas bills. All of the building focused tools that that Brittany was showing earlier, like ResStock and Comstock and BuildStock, all of those estimate energy usage across fuels. So not just electricity or natural gas, but also fuel oil, which is like more relevant for the Northeast for heating. And Cairo can estimate natural gas bills, but so Cairo will optimize electricity rates and calculate bills for electricity. It largely takes the natural gas rates as a given. So you can give it, and that's to help inform total affordability estimates. And we've combined that with sort of simple proxies for gasoline expenditure, like very, very top level stuff, to try and give a picture of this is your across the board energy related expenditures. And that's important if you want to look at, does somebody theoretically save money from getting an EV? Because their electricity bill will go up and you have to somehow account for the fact that their gasoline bill will go down.
Got it.
I hope that addresses.
Thank you. Do any of you have particular insights on rates in localities that have community choice aggregations?
I don't have anything off the cuff. We have studied CCA regions in the past. I think this is a really excellent example of something that needs more analysis, is different rates in different regions or structures, utility structures. So yeah, this is highlighting a great example of something that we could dive into in more detail.
That's great. Okay, next is, in one of the slides, you find that fair cost allocation may depend on the number of customers on each transformer. Will you please explain more? How is this seen in practice?
Yeah, so for that, basically, like, the sort of crux of that argument is that residential customers' individual non-coincident peak demand could impact the size of a utility's transformer, but doesn't impact utility equipment beyond the transformer. And in cases where each customer is attached to just one transformer in like rural areas and C&I customers, there may be a better correlation between individual non-coincident peak demand and the size of the transformer. But the circumstances change slightly in urban and suburban spaces, where the transformer is serving 5 to 10 customers, or even more in the case of apartments. They may not have as strong of a correlation with transformer sizing. So that's sort of what that was getting at.
Thank you. Does NREL have any resources for customer transparency on time of use rates, such as shadow billing or rate comparisons?
Not that I'm aware of. That's a really great question. I think that understanding best practices on how to communicate with customers regarding their specific rates and how to increase affordability is something that we should all focus on more, is that communication with customers.
Yeah, fully agree with that. Do you happen to have any examples of utilities that have successfully marketed residential demand rates to their customers?
I think the ones that we know of were at the top of that table in slide 20. So APS, I think there was one other one that has like over 1%, but I'm blanking right now. Avista Corp, which that one is kind of weird because it includes a residential and farm general service rate in the URDB. So we need to just do a little more research to understand whether those customers would be categorized all in the residential service class or sort of like in another class. But Arizona Public Service is probably the best example of that.
Great, thank you. Are there examples of residential demand rates that are tech specific? For example, homes using heat pumps?
I don't think so, but that is something that came up in some of our interviews. People were sort of thinking about similar questions. So that's a great question, but I don't know of any examples of that.
Yeah, I think that's a direction that rates could go in the future is technology specific rates or rates that are tailored to customers that have particular technologies. And I think that's a great example of how rates can get more complex, but more nuanced in order to increase flexibility or increase affordability for certain customers and really bring the best benefits to the grid as well. So these very nuanced rate designs that we haven't really been able to have in the past that are now not only called for, but I think technology is going to allow for.
Thank you. For customers that have the demand charges, commercial, industrial, or residential, were you able to determine if the effective electricity burden was generally higher or lower than for customers without in the same general areas?
I think that wasn't in our scope for that particular project, but that's an interesting question. And I think NREL has the capability to evaluate sort of questions like that.
Great. All right, another Cairo question. Does Cairo capture transmission and capacity costs? And then there's a part two, but I'll let you answer that, Thomas, if you're ready.
Yep, and I've been trying to address some of these in the chat, but so Cairo takes costs at a couple of different stages, and it does different things with those costs at different stages. So at the highest level, Cairo needs a revenue requirement, and it can be a bit of pre-processing work to if you're trying to develop a bottom-up estimate for the utility revenue requirement, like that will require some work, and and we've done this using either we get a existing estimate from the utility, either from a rate case or from an IRP, or they hand us one because we're working with them directly. Other times we're taking estimates from our own sort of bottom-up forecasted power system scenarios. But you give Cairo a top-level utility revenue requirement, and that will have to include transmission and capacity costs. And typically, because Cairo analyzes it at an individual customer class basis, there's a step of what is the total cost of the utility and how much do we want to allocate to this particular customer. So there's a bit of a two-stage there. But it will take transmission cost, capacity cost, whether that's coming from like a vertically integrated utility structure, or you're trying to estimate capacity cost based off of capacity market values. The other place that Cairo will take costs is when it's looking at marginal cost, and we use that to inform rate design. So we'll look at marginal cost, including, when is the peak period, et cetera, to try and figure out if there was a time of use rate here, when would the peak period be, or when would the off-peak period be, or when would the shoulder seasons be, et cetera. And then, when customers respond to time of use rates, we want to try and capture the savings that they see. So that's when Cairo would take marginal costs. I hope that addresses the can. The high level answer is yes, it does consider, it tries to capture all of the costs that the utility has to collect from the customer. Otherwise, it wouldn't be a complete picture of their rates.
Okay, great. Thank you. Well, I see somehow we're already at time. Thank you so much, Thomas, for answering some of those questions in the actual Q&A, and for Brittany and Joyce for your excellent presentations and answers to the questions as well. We're very grateful to have you here. NREL has the questions that you submitted, and we'll be able to parse through them and get working on the ones that their capacity allows for. So hopefully we'll be able to see new research and new analysis on a lot of these topics. So thank you for your contributions and for your feedback. And we hope to see you again on a future CESA webinar. And if you need to exchange contact information or need any of the other resources that we talked about here, or just any assistance in general, please feel free to email one of us, get in touch, and we will be connected. Thanks all for joining, and have a great rest of your day. Right.
Thank you.
Thanks, Brittany.